Hello guys, how are you? Welcome back. Ka topic ya rona ya radioactivity. Yaanong ra go simolla from uses of radiation. We'll briefly mention detection. Okay, detection ya kana ntse ke supile mo the previous lesson. Re detector radiation ka GM tube. So ke yone GM tube ye. GM tube, we just call it GM tube, right? Is one to detect radiation. Our level learn the uses of radiation. So the first thing that we are going to talk about more the use of radioactivity is thickness gauge. Radioactive isotopes help manufacturers to check and carefully control the thickness of a product like a duplicating machine paper. Okay. So radiation source. Time radiation. It will be hit through this paper. Okay. High hit through this paper. What happens? It is detected by the what? The GM tube. GM tube can detect the amount of radiation that reaches the GM tube. Okay. Harna le roller tsepedi, more it's a control unit. It's a control unit. Okay. I remember pencil ko akitsora ke junior kana ke senior. Kone re rutwa how the nerve system bereka. I remember lesson ya gore how a message is sent to your brain gore hela kana kwano tatama ke re legala ha o gata legala ka loto la gago ya message wa sendiwa go tlhaloganya gore hela kana loto kwa lasha le go dimo ga se semollo tlhaloganya ke ne tabe re okay fine la re go gatilwe legala go ko tasiko then tlhaloganya tabe ya gore e senda message gape gore nya tsamara loto le gore le tshuletse ga yes then loto le tshuletse gore a sema go teng gone it seems like it's automatic of course but gona le di messages tse di relaywa okay that's why how twila metso sa ga wa tola ya o ga itela o shile tota wa go thanya pele be le gone ra sna now time e be le gone ka le kang go sia le gore go mo mollo okay so the same thing happens here ye control unit ke boboko thogo okay thogo ya nenyane ya thickness gauge machine so hana go gore hello radiation e heta ilentsi message will be sent to the control unit. The roller arabe behavior in a certain way. No are simololeng. Ketare thickness ke boka he for argument's sake 1 mm. Ke yone ntsenya e ba tiwang a ke source ke yone entshaeng radiation through the paper. E be balwa ke eng ke GM tube aga GM tube ang go le GM tube e bala 20 aga e bala 20 which is good aga A B situation B ona go kima ya ke go ile go kima ka bo na ke se fetsela ke go ile go kima ka bo nenyane ye anong e bala bokae 10 ke GM what GM tube e bala 10 so ha bala 10 how many millimeters kana are 2 millimeters so guys go hana re bata re ne 1 millimeter me ang ke 2 millimeters tota ha re se re itse ka 2 millimeters rena re bona kae re bala 10 activity ke 10 re bala 10 yana gora re di particles tsa radiation di heta di le dinnyane yana ka gore go mo go kima thata only a few manage to penetrate through gore pampiri ya rena ikima that's why ke ile example ya 2 mm ha ile kimana control unit e tla be ra roller le relaxitse irang yang pressang oketsang pressure roller oketsang pressure pampiri e ne tshesane e boele go 1 mm a ke re tabe go itira e be boela go 1 mm. Scenario 3C. Pampiri here, guys. I got to go sepe se sentse I get you ya no ile ge. Well, na re mo go scenario number 3, right? Let me redraw it. Scenario number 3, the source of radiation. I get pakwane nale GM tube. So remember na really it's hanzo renne bokae. Ideally it's hanzo bala 20. I get ideal. This is the correct one. Moke source. Yanong se sira halang ha yanong imo go 40. E bala 40. Ha bala 40 ra gore guys. Ra re yanong pampiri ile tala radiation entse gore hit. Mo go rang gore pampiri yanong e tshesane thata. This is the paper straight. Right, e tshesane thata. Go ra gore ye rollara ya apply le pressure entse. So control unit ha e bona gore reading yanong ke 40 instead of 20. Tabe send a message to the rollers or go tsang pressure. Ya go emisa molaetsa wa go tsang pressure ha e nna bokae 20. So this is how thickness gauge works. I get. Yes, let's look at the next item. Yanong ha go tlhaloswa sone se re ntse re se bua I get. Me yanong se sa botlhokwa hela ke gone gore re lemoge gore ke the same thing tota. Okay, let me just go through this. Okay, a radioactive isotope is placed on one side of the material and the detector on the other side. The amount of particles radiation reaching the detector is monitored closely by the machine operator or control unit. If the thickness of the material, which is paper, increases, fewer particles will reach the detector and vice versa. The isotope has to be chosen to suit the requirements of the manufacturer. For example, a beta source will be more suitable for a steel mill. Gamma sources are not suitable since gamma is very penetrating. So gamma ra ya go nna e pheta hela. Yanong le yone ya pampiri guys ra go choose beta particle ka gore alpha yone ya go emisiwa ke pampiri ra ya hela ile re ntse e eme ya ka o bone ka kwa re supile gore emiswa ke pampiri. So e suitable ke beta particle e ta nna ntse khona go eta through this paper. I get. Yes, na ke batla go emphasize kganya gore beta ke yone suitable gone ha. So other uses e ka nna sterilizing of surgical equipment. Surgical means placing seal bags and then exposed to short bursts of gamma radiation. The gamma rays kills any microbes inside the bag and the contents will remain sterile until the bag is open. Okay guys, ke tsa gore la itse gore ha o ka re o kentiwa ko clinicing a ka ra tsa mo kenta no re go kenta ka one be re nya ba bangwe le bone tsena mo lining ra le kenta re shuthalana ka hand paper towel kana ka letsela di bacteria ja go salla di bacteria nyana ja go salla le megarenyana ke. So with gamma e ta khona go bola everything. Akere remember gamma ke yone irisiwa le go bola cancer cells mo mmeleng ya rona ke ga ona le cancer ke gamma ke yone ta be irisiwa gone ho. So to sterilize surgical equipment. Ye bile ga bua hacker. Yeah, you can sterilize. Another use is to kill cancer cells in human bodies. Yes. You got the long life fruits and vegetables. Yes, le ona ntse ke the same. Ha so se senyega normally. Sa se sengwa ke gona gore go na le tsone microorganism. Ke tsone tse di ra re di bone tota. So ga re kgonne go deala le tsone dio di a kgona go tsaya lebaka le le leele di ntse di ka jega we also have medical tracers be re nna le ene ile le ne ka taba tlhalosa ka re ke ne ka reng e ka bata a little bit of understanding. Radioactive isotopes can be used as tracers to detect leaks in underground pipes for gas, water, and sewage. A small amount of gamma radiation source is injected into the pipe, and the leak can later be detected with the GM tube. So go ra ga go sentswe radiation nyana so go na le radiation. So ha re tsamaisa GM tube go di mo ga pipe yana re khona go tsamaya re bala gongwe re badile le 20 ha e no go na le phathanyana teng ya radiation ya go tswa ile ntsi re ta bona machine o bala di value tse go di mere bona go ra go ne go na le mathata go na le leakage ka gore re detect more radiation. Yes. In agriculture, isotopes can be used as tracers to find how fertilizers and other nutrients are used in plants. Yes, and then we also have carbon dating. Carbon dating is just to mention it. Then the dangers of radiation. The danger from alpha particles is slight. Large doses of beta and gamma can cause radiation burn. Gamma electromagnetic spectrum. For gamma e cause cancer. Yes, gamma cause cancer. Safety, handling, and storage of radioactive isotopes. Even radioactive material emits low levels of radiation, e.g. materials used in schools or laboratories, it must be handled with extreme care. Handling always handle isotopes using forceps or special gloves. Keep away from eyes. Do not point the source towards any person. Always wash hands after handling. Storage. Keep the samples in special boxes lined with lead. Store boxes in a locked cupboard. Disposal of radioactive waste. Burn low-level waste or bury it in the ground or release it into the sea. High-level waste in steel drums are buried in disused mines or granite caves or buried in concrete and dumped in deep oceans or stored at special factories for reprocessing. So you can read and maybe try to take a short note of this. Yes. Background radiation. Background radiation allows na source anyway close. Background radiation. So background radiation. It is a low-level radiation that is always present around, mainly because of the radioactive materials in the ground and air. Every person on Earth is exposed to this form of radiation. Major sources are rocks, soils, and underground water, cosmic and solar rays, food and drinks, man-made radiations building. Surrounded with this, so background radiation in radiation source around me, background, but it's low level. the detecting alpha, beta particles and gamma rays by investigating their penetrating ability. Again, example ya rona ke yone, example ya rona ke ye, mme yaanong re ta e lebelela re kopantse le this table. So the best thing that we should do, guys, ke gore re eme go neya ka this lesson. Re ta tswella on the next lesson, okay? Because we have to explain a few things here. Ya go bona ke tshwantse tsana re ta tshwantsha gape re supe re ira di-line re bua gore material ke eng hela yalo. Okay, so thank you guys, let's meet on the next lesson.